All right, this is A1 notation, the first homework. So let's get it. Um, Number one. So we're given one piece of information and we have to fill in the rest of the blanks basically. So we're given that x is less than or equal to 3. All right, so let's graph that. Less than or equal, so that's a closed circle at 3. And it's less than, so it's to the left. So we'll shade to the left. Okay, in interval notation, remember this is the use of infinity if we need to and no x. So this is going to be, since it's to the left, negative infinity, since it always gets the parentheses, up to 3. We include 3, so we get a bracket. All right, for set notation, curly bracket, we put the little verbiage that we put every time when it's a line like this. So our variable is x, such that we know that x is a real number. It's continuous, right? It's on a number line. And then we put the inequality. So x is less than or equal to 3. Too easy. All right, moving right along. Number 2, we're given that the interval -4 or negative infinity up to 4. So negative infinity up to 4. And it's a parenthesis, so it's open circle towards negative infinity. The inequality for this is similar to what was in number 1. So x is less than, strictly less than 4. Set notation, curly bracket. We're dealing with x's. We know that x is a real number and x is less than 4. All right, number 3. So here we're given the graph. Closed circles at 2 and 6. So 2 and 6. So x is between, everything in between 2 and 6. Positive 2 and positive 6. So 2, 6. We know x is in between. So less than or equals, less than or equals. Okay, for the interval, we're between 2 and 6. And we include 2 and 6. For the set notation, curly bracket always. And we're dealing with x's. We know that it's a real number. Right? X is a member of the real number line. And the inequality that's involved. So whatever we wrote as the inequality, that's what we write here. Right? X is in between 2 and 6 exclusively, meaning it could be 2 and it could also be 6. All right, number 4. We're given the interval. This time it is 5 to infinity. 5 to positive infinity. So closed circle at positive 5. We go towards infinity, positive infinity. The inequality for this is going to be, so we have to compare x to 5. Typically, we write x first, and then we write 5. You can do it the other way, but I typically write x first. So we know that it's going to be greater than 5. So x is greater than or equal to 5, since it's a closed circle, a colored in circle. All right, set notation for this guy is going to be curly bracket. And again, x, that's the variable we're dealing with. And x is a real number. We know that x is greater than or equal to 5. Hopefully the pace isn't too fast for you guys. You can always pause it. moving up. All right, number 5. Again, here we're given the graph. All right, so we're at a closed circle at 1, and we're going to the left towards negative infinity. Right? Negative infinity is always to my left. Inequality for this. So we compare x to 1. Right? We never put infinities in the inequality column, or whenever we're doing inequalities. Infinity is never written as an inequality. You always just compare x to whatever numbers or endpoints that you're given. So we want all the numbers smaller than 1. So x is less than or equal to 1. For the interval notation, you can use infinity. In fact, we're going to use infinity right now because negative infinity is to the left and we go up to 1. So infinities always get parentheses no matter what. And it's a closed circle, so 1 gets a bracket. For set notation, we get the curly brackets. We write the part that we always write, x, such that x is a real number. And then we write the inequality that's involved. X is less than 1 or equal to 1. All right, number 6. We are given 2 inequalities now. X is less than 1 or x is greater than or equal to 5. So the first one, x is less than 1. So open circle. And we know that it is less than 1, smaller than, towards negative infinity. The second piece, x is greater than or equal to 5. So close circle at 5. To the right. So here's my graph. It's 2 pieces. 2 inequalities equals 2 pieces of graph. For the interval, we're going to have 2 intervals as well. And we're going to union these guys together. So what I'm saying is, from left to right, we have negative infinity up to 1, but we don't include 1 because it's an open circle. Union, the second piece. Brackets because we want to include 5. And then we go up to infinity with parentheses. All right, for the set notation, curly bracket. We always state x such that x is a real number. And then we write the inequalities that are involved. Right now there's 2. X smaller than 1. And can I fit it in here? X greater than or equal to 5. There we go. Number 7. Here we have, so from negative 5 up to negative 1. But it's an open circle, so we don't include the ends. So this is saying, and everything in between, right? Between negative 5 and negative 1. So negative 5 less than x less than negative 1. And for the interval, negative 5, comma negative 1. Parentheses, because we do not include the ends, negative 5 and negative 1, because of the open circle. Curly bracket for set notation, always. The thing we write, x such that x is a real number, and then the inequality that's involved, negative 5 less than x less than negative 1. All right, here's a tricky one. Number 8. They're saying that x is any real number. So this number line is the real number line, right? Every real number is on this number line. So x could be any of these from negative infinity to infinity. So there's 2 ways that you could write this as an interval. One way, you wouldn't be wrong, would be the whole interval. Negative infinity to infinity, right? There's nothing wrong with that. Or you could just say the real numbers, right? The real numbers. So bold R, bold struck R, the real numbers is essentially negative infinity to infinity, right? It's up to you. Both of them are correct. So negative infinity to infinity is how you say all real numbers. Or you just put the bold struck R, and that is all real numbers as well. For set notation, put the curly bracket. We could say, so for this guy, all right, so we know we're talking about X. And we know that X is a member of the real number line. And I feel like that's really all we need to put, right? Because there's not, X is a real number and it could be any number. So there's really nothing else to put. I mean, if you wanted, I guess you could write this. X is any real number. But I feel like that's a little overkill, right? Because I feel like we're already saying it, right? Because if you think about it, up here in the previous one, we're saying X is a real number, but then we're restricting it, right? Between -5 and -1, right? Like we have all these restrictions. In this particular example, we don't have any restrictions. So kind of implies that we're talking about every number. So we could leave it blank. All right, for number 9, we have two pieces again. So we're at -1, and we're going towards negative infinity. So X is less than or equal to -1. Then we have at +2, open circle. So X is greater than +2. Right, open circle, don't include. Intervals are going to be negative infinity up to -1 with the bracket. Union, because it's two pieces, starting at 2, we don't include 2, towards infinity. All right, set notation will be as follows. Curly bracket, X, we know that it's a real number, right? Because it's on a number line, the real number line. And we have two pieces, X less than or equal to 1, X greater than 2. Okay. Number 10. We have interval 1 to 4. So parentheses, so that means we do not include. So open circles on 1, open circles on 4, and everything in between. So the inequality for this is going to be X is between 1 and 4 and less than. 1 is less than X, which is less than 4. For the set notation, curly brackets, X such that X is a real number and X is between 1 and 4. But not 1 or 4. Be clear on that. All right, number 11. They say X is greater than 7, but not 7. So here we have open circle at 7. X is greater than 7. So we go to the right. So from 7, parentheses, all the way to infinity, parentheses. Because parentheses always gets or infinity always gets the parentheses. So the set notation, curly bracket, X, such that X is a real number and x is greater than 7, but not 7. All right, number 12. We have an interval, -2 to 2, including -2 and 2. So from -2, close circle, to +2, close circle, and every number in between. For the inequality, -2, +2, x in the middle, less than or equal, less than or equal. Right, because x is every number in between -2 and 2 and everything in between, and including -2 and 2. Okay, set notation, curly bracket, part that we always write, and -2 less than or equal to x, less than or equal +2, curly bracket. We're almost done. 13. We have -3, open circle, 0, close circle. So -3, strictly less than, x, less than or equal to 0. And interval, we have -3 on the left, comma 0. -3 will get the parentheses because of the open circle. 0 will get the bracket. Set notation, curly bracket, x, such that x is a real number, and x is between -3 and 0. Could be 0, but it's definitely not -3. 14. It's kind of like what we just had, right? Except it's kind of switched. X is between 0 and 3. So close circle at 0, close circle at 3, and everything in between. On this interval, we have 0 on the left, 3 on the right. 0 will get a bracket because we include it, close circle, as will 3. 3 will get it also. All right, last set notation, curly bracket. We know that we're talking about x's. We know that x is a real number. It's on a number line, the real number line. And we are going to use x is between 0 and 3 exclusively. All right, that's the front. So to the back. All right, here we go. Jack runs an average of 3 miles per hour. Write a function d of x that gives the distance she runs in x hours. So Jack is a girl. We're going to start at 0 because she hasn't ran yet. So 0. Now on an average of 3 miles per hour. So if we label our axes, I guess we could have did that first actually. So y and x, 0, 0 is still on there, like regardless. So we have distance, and then we have time. Distance and time. All right, at 0 time, Jack, she has ran 0 miles. After 1 hour, she runs 3. So you could, however you're going to label this, you could label these 1s, 3s by 3s. It's really up to you. I mean, technically, let's just do 1 and see what happens. So we have 1, 2, 3, 4, 5, 6, 7, ... All right. 1, 2, 3, 4, 5, 6, 7. All right. After 1 hour, she runs 3 miles. After 2 hours, she runs 6. 3, she runs 9, which is like up here. So we're off the charts. We could have adjusted a little bit, but you know, Jack doesn't run often, so she only ran for 3 hours. Okay, so now after you put your dots, you have to ask yourself, do I connect the dots, right? Do I connect the lines? Don't just randomly do it every time, right? It has to make sense, because the idea of it being continuous or it being discrete, right? If it's discrete, it's just dots. So you have to ask yourself, really, do the halves make sense, right? At 0.5 hours, is it possible to run just 30 minutes? Well, yeah. In 30 minutes, she ran 1.5, right? Half. She just doesn't jump over, you know, time or distance. So the halves definitely make sense in this context. So we can connect the dots. All right. And for this particular example, the function we'll call d of x is going to be 3x, right? Because every hour she went 3 more miles, right? 0 times 3, 1 times 3, 2 times 3. It's all on this line. Then we graphed it. And is it continuous or discrete? Well, it's continuous, right? Because it's a continuous line. Time is continuous because time is continuous. The domain for this is going to be, in theory, the most, like the smallest amount is going to be 0, right? Because x is the time, right? Domain is x, which is time. The smallest amount of time that she could run is 0. And the largest amount of time, in theory, is going to be infinity, right? In theory, because we don't know when they stopped. Can they run forever? No. Is this reasonable? Probably not. But in theory, she could run forever. A reasonable answer? Probably like a couple hours. The range is the y values. Again, starting at 0 before she's even moved, up to some number infinity. Now, say if we just said, okay, she only ran 5 hours. If this was 5 instead of infinity in the domain, well, then the range would have to reflect accordingly, right? 15. If we did it right, but I'm just saying. I'll leave it. All right. The independent variable, this is always the x value, right? Whatever the x value is. Here, the independent variable is time in this situation. The dependent variable was the distance. Right? Time does what it wants, and the distance will depend on the time. Right? That's how the function is set up. The input, you input the time. I'll tell you how far this person, Jack, she ran. All right. Second one, last one, actually. So a ticket to ride the bus is $1.50. Write a function c of x that gives the cost of riding for x amount of times. So again, we label the axes, y and x. This is the dollar amount. This is the number of rides, number of tickets sold. Okay. At 0 times, if 0 tickets are sold, not times, but 0 tickets sold, 0 money is made. 1 ticket is sold, then it's going to be $1.50. So again, we could do this by ones. You could use $1.50 if you want, but I try to keep these as whole numbers. So if 1 ticket is sold, it's $1.50. 2 tickets, $3. 3 tickets, $4.50. 4, $6. 5 tickets, $7.50. All right. So here, after we have our dots, do we connect the dots? That's the question. So does it make sense to sell half a ticket? Can you buy half a ticket? No. You can only buy a whole number of tickets, or you don't buy a ticket at all. So it doesn't make sense to connect the dots because there's no such thing as the halves or the quarters or the 3/4 or whatever the case is. Any number in between a whole number doesn't make sense. So this is definitely what the graph looks like right now. We could kind of skip ahead. This is definitely discrete, right? It's discrete because you can't buy half a ticket. Can't buy half a ticket, in other words. Okay, the function, however, we want to make c of x. So the trick here, the slope, right, is the same everywhere. It's increasing by $1.50 every time, from 0 to $1.50, plus $1.50 more, $1.50 more, $1.50 more, right? Like the slope is $1.50 basically. So we have $1.50 x. All right, in set notation, we're going to write all of our x's that are used, right? And in this one, let's just say, keep things simple. They only sold 5 tickets. A slow day at the Greyhound. So 1, 2, 3, 4, 5. It could be more, but for my scenario, they only sold 5. Technically, 0 is in here as well, right? Because 0, you could sell 0 tickets. So these are the numbers that are used. The range is going to be all the y values. So this is going to be 0, 150. What is this? 3, 450, 6, and 750. So that's the range. The independent variable is the number of tickets. And the dependent variable is the amount, the cost. How much money did you make? Well, you got to know how many tickets you sold first. That's how the function's set up, right? The money depends on the amount of tickets sold. All right. Well, that's the homework. Hopefully it helps you guys out. I'll catch you guys in the next video. Peace.